Hey there, space enthusiasts! Welcome to Tech and Time Journeys. Ready to have your mind blown by some incredible facts about our universe? From supermassive black holes to the Fermi Paradox, the cosmos is full of wonders. Let's dive into the top 9 mind-blowing discoveries about our universe. I bet you didn't know about supermassive black holes. These objects are the true behemoths of the universe, some containing billions of times the mass of our Sun. Imagine the Sun, a star that could hold 1.3 million Earths. Now magnify that by a factor of billions, and you start to grasp the sheer scale of these cosmic monsters. At the heart of almost every large galaxy, including our own Milky Way, lies a supermassive black hole. These black holes are not just cosmic vacuum cleaners. They play a crucial role in the evolution of galaxies. Their immense gravity holds galaxies together, shaping their structure and influencing star formation. Think of them as the conductors of a cosmic orchestra, their gravitational pull guiding the movements of stars and gas clouds. So the next time you gaze upon the night sky, remember those silent giants at the heart of galaxies, shaping the cosmos with their immense gravity. What's something people don't know about the earliest moments of the universe? What happened after the Big Bang? Well, we have a way to peer back in time to just a few 100,000 years after the Big Bang. It's called the cosmic microwave background, or CMB for short. Picture this. The universe is a baby, just a few 100,000 years old. It's a hot, dense soup of particles, and light can't travel freely yet. Then, as the universe expands and cools, something amazing happens. Light breaks free, and it's been traveling through the cosmos ever since. This light, now stretched into microwaves, is what we detect as the CMB. Think of it as the faint afterglow of the Big Bang, a cosmic echo that carries information about the early universe. By studying the CMB, we can learn about the universe's age, composition, and even its geometry. This uniformity tells us that the early universe was incredibly smooth, but with tiny fluctuations in temperature. These fluctuations represent the seeds of the galaxies and galaxy clusters we observe today. Am I the only one that didn't know that what we see in the universe, all the stars, galaxies, and planets, makes up less than 5% of its total content? The rest, a whopping 95%, is made up of something we can't see or fully understand: dark matter and dark energy. Let's start with dark matter. We know it's there because of its gravitational effects on visible matter. Galaxies rotate faster than they should based on the visible matter alone. Something unseen is providing the extra gravity to hold them together. That something is dark matter. But what is it made of? We don't know. It doesn't interact with light, hence the name dark. It's like a ghost, passing through the universe, only interacting with gravity. And then there's dark energy, even more mysterious than dark matter. It's causing the expansion of the universe to accelerate. I bet you didn't know the universe wasn't always here. It had a beginning, an event that scientists call the Big Bang. Imagine a point smaller than an atom, containing all the matter and energy of the universe. Then, about 13.8 billion years ago, it exploded. This wasn't an explosion in space, but rather an explosion of space itself. The Big Bang created space and time as we know them, expanding in all directions at an incredible rate. As the universe expanded, it cooled and energy converted into particles, forming the first protons, neutrons, and electrons. These particles then combined to form the first atoms, mostly hydrogen and helium. Over millions of years, gravity pulled these atoms together, forming clouds of gas that eventually collapsed to create the first stars. The Big Bang is a mind-boggling concept, but it's the best explanation we have for the origin of the universe. I bet you didn't know that gravity isn't the only force at play in our universe. It's the force that keeps us grounded on Earth and the Moon in orbit around our planet. But what if I told you that there's a different kind of gravity, one that pushes things apart? It sounds strange, but that's precisely what scientists believe is happening. The expansion of the universe, which we've known about for nearly a century, is not slowing down as we might expect. It's accelerating. And the culprit behind this cosmic acceleration is a mysterious force called dark energy. Unlike gravity, which attracts, dark energy repels. It acts like anti-gravity, pushing galaxies apart from each other at an ever-increasing rate. Imagine a loaf of raisin bread dough rising in the oven. As the dough expands, the raisins, representing galaxies, move farther apart. That's a simplified analogy for how dark energy affects the universe. But here's the catch: we have no idea what dark energy is. This is gonna blow your mind. Deep within the core of our sun, a star, a giant nuclear fusion reactor is constantly at work. Every second, hundreds of billions of neutrinos are born from these nuclear reactions, streaming out from the sun and into space, passing through everything in their path, including our planet. Neutrinos are fascinating particles. They're incredibly tiny, nearly massless, and they rarely interact with matter. They are like ghostly travelers, passing through planets, stars, and even our bodies without leaving a trace. For decades, scientists studying the sun were puzzled by a discrepancy. They were detecting far fewer neutrinos than predicted by our models of nuclear fusion. It seemed like the sun was producing fewer neutrinos than it should, which challenged our understanding of how stars work. The solution to this mystery came from a remarkable discovery: neutrino oscillations. It turns out that neutrinos come in 3 different types, or flavors. As they travel through space, they can change from one flavor to another. This discovery explained why we were detecting fewer solar neutrinos than expected. I don't think people understand the sheer diversity of planetary systems out there. For centuries, we humans could only marvel at the planets in our own solar system, wondering if there were other worlds out there, orbiting distant stars. Then, in the last few decades, came an explosion of discovery exoplanets. Exoplanets are planets that orbit stars outside of our solar system. They come in a stunning variety, challenging our preconceived notions about planetary systems. We've found hot Jupiters, gas giants orbiting scorchingly close to their stars, and super-Earths, rocky planets larger than our own. There are planets locked in synchronous rotation with their stars, with one side always facing the star, resulting in scorching hot days and eternally dark nights. We've even found planets orbiting pulsars, the rapidly rotating remnants of dead stars. The diversity of exoplanets is astonishing. I bet you didn't know about the detection of gravitational waves. Imagine a still pond. Now toss a pebble into it. What happens? Ripples spread out from the point of impact, disturbing the surface of the water. These ripples carry energy and information about the event that created them. Now, imagine something similar happening in the fabric of space-time itself. These ripples, called gravitational waves, are disturbances in the curvature of space-time, caused by the acceleration of massive objects. Albert Einstein predicted the existence of gravitational waves in 1916 as part of his groundbreaking theory of general relativity. However, it took nearly a century to develop the technology sensitive enough to detect them. In 2015, scientists made history by directly detecting gravitational waves for the first time. This detection was a monumental achievement, confirming Einstein's predictions and opening a new window into the universe. Everybody is looking for answers to the Fermi Paradox. Look up at the night sky. It's filled with stars, billions upon billions of them, each a sun, potentially with its own system of planets. Given the vastness of the universe and the sheer number of stars and planets out there, it seems statistically improbable that we are alone. Yet, despite decades of searching, we have found no definitive evidence of extraterrestrial life. No radio signals, no alien artifacts, no signs of advanced civilizations. This discrepancy between the high probability of extraterrestrial life and the lack of evidence is known as the Fermi Paradox. So, where is everybody? There are many possible solutions to the Fermi Paradox. Perhaps intelligent life is incredibly rare, and we are one of the first civilizations to emerge in the Milky Way galaxy. Or perhaps, interstellar travel is incredibly difficult, and civilizations are isolated from each other by the vast distances between stars. It's also possible that advanced civilizations have a limited lifespan, succumbing to natural disasters, self-destruction, or other unknown factors. The Fermi Paradox remains one of the most intriguing puzzles of our time. And there you have it, 9 incredible facts about our universe. Which one blew your mind the most? Drop your thoughts in the comments below, and don't forget to like and subscribe for more cosmic content. Until next time, keep looking up.